Hello everyone, good evening to all. Today I am going to solve a question on starters 121. The question is Caesar cheaper light. The question says you recently read about the Caesar cheaper, one of the fast and the easiest to break cryptographical algorithm known. Since it was very easy to break, you decided to improve it by building a light version of it. Here it your modified algorithm. Suppose you want to encrypt a plain text P of length n. First you generate a secret cryptographical key K, which is an array of length n. Then for each I from I to n, you perform KI Caesar 3 shift on character P of I. A Caesar 3 shift is defined as replacing a character with a third next character in the English alphabet. This is done cyclically, mentioning a character A in the next character to the character Z. For example, performing a 3 single shift of Y will result in B. Let's denote the encrypt cheaper text of a plain text P using a key K. For example, if K equal to 10, 40, 10, 14, 15, EK pass equal fail. Now after a long time you perform that K what K was. However, you have a plain text P and its encrypted ciphertext C. Your task is to find the lexicographical smallest array K such that EKP equal to C. It can be shown that such a K always exists. An array X is lexicographical smallest than another array Y of the same length if the first position I where X and Y differ, Xi less than Yi. Here the question says in the test case, in the question you can shift a 3 shift. If A, you can shift A with D and then D with G. Then if you can shift A with D, then D with G, then D with I with L with O. Simple like this. So you have to find the number of times you perform the operation to find the same digit. To find the, if in the test case you are given A, B, C and G, B, Y. In the number of operation, in how many operation you find A, you can move from A to G. Here from A you can move A you can move D, then D you can move G. So there is 2 operations. In the question, the first test case is A, B, C and G, B, Y. In the question, it is not clear that what to implement in the question. So if you don't understand the question, then see the test cases, then you easily understand that what to implement in the particular question. So let's see. In the question says you can replace A with D, then D with G, then D with J with M. You can move from here to here, here to here, here to here, not here to here, here to. You can shift 3 position here. If A, B, C, D, E, F, G, H, you can shift here to here, here to here, then here to here. So simply in the test case given A, B, C, to reach G, we can move A to D, then D to G. In the B there is no move required. So here k equal to 2, here k equal to 0, here k equal to. In C you can move E, C you can move F, in F you can move I, if from I you can move L, from L you can move O, from O you can move O, R you can move U, from U you can move X, you can move A, you can move D, then you can move D, E, F, G. So from G you can move G, H, I, J. From J you can move M, from N you can move P, from P you can move S, from S you can move V, you can move from V you can move Y. So finally you can reach from here to k equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So in this case k equal to 16. In 16 case 16 move you can reach from C to Y. So simple. We run a loop to find the number of k so that we can reach from A to the target, from initial position to the target letter. So let's come to the test cases. In the test case, if you see the test cases, then you can easily understand what can you implement. So this the question is little bit means you cannot understand directly by reading the question, so you have to see the test cases. So let's come to the coding part. I have implemented the same which I explain in pen and paper. So here is the two string. I take input, then I create a loop in case of I we take first character. In case of A, B, C, G, I, first A and G, first S1 equal to A and S2 equal to G. In the simple I, minus 65 means A. The SKI value of capital A is 65. Then we call the function. Here the find function. In the find function we have run a while loop. While S1 equal to S2, we run the loop. We simply do C++, which is equivalent to calculate the k. So simply store in the array of I, and so then in the last, after calculating all the position in the array, we store the array, then we print the necessary then we print the value of k in every iteration. So now I am going to submit the code. First I run the code to test that if I am true or some else. Then I am going to submit the code. It gives TL. Simple. 65. Let's take 65. It gives time limit exit in the code. Here I made the mistake. It should be 64. So now let's submit the code and see what happened. I think it will get accepted. Let's see what. Yes, it got accepted. So thanks